All right, so today I'm going to do a bit of a live stream here. I'm just trying this out. Don't really know how this all really works, but anyway, let's give this a go. And I wanted to make this stream all about choosing the right tools for data analytics and data science. Now, this is a question that comes up quite a bit of the time about what tools should I actually use. There's basically dozens and dozens and dozens of tools, and you could basically spend hours and hours chasing down all kinds of different rabbit holes trying to figure out what to use. So I have a small list of tools up on the screen here. We've got the icons here for Excel, R, Python, Access, Tableau, Qlikview, Power BI, and other things as well. So now, a lot of times people get into these conversations about which tool is best, and it's often not really about best. It's often about what tool is going to be kind of really appropriate for the job. Now, if you're joining, by the way, just it'll be great to have a little shout out. So I'm not just talking to myself. Let me know what tools that you are using, what tools you'd like to use, where you're at in your data science, data analytics journey. Are you just starting, or have you, are you already a practitioner, already using a whole bunch of different tools and just want to find out about other things? Leave a little message in the little chat box, and it'd be great to find out, just to make this whole thing a little bit more interactive. But anyway, so like I was saying, there's a whole bunch of different tools, and these things are really used for lots of different types of purposes. So Excel is, well, it's a spreadsheet, right? And spreadsheets are, in some sense, are a kind of advanced calculator. Then you've got things like R and Python. Now, I have another video on my channel which is comparing R and Python. So if you want to check that out in a little bit more detail, there's a video that does the comparison between those two tools. But you could effectively bucket them into the same category because for the most part of it, they are actually pretty similar. It's just that R is a more sort of data specific programming language, whereas Python is a more general programming language, which has libraries which kind of mimic the functionality of R, basically. And it does lots of other stuff as well. So then you've got things like SQL, like databases, like Access databases, SQL Server, Oracle, and all these kinds of things. And and then our kind of fourth category is we've got now all these kind of data visualization tools. Now, of all the different data visualization tools, Tableau is probably the most popular of all of them. But then you've got others as well. Like, for instance, you've got Qlikview, QlikSense, Power BI, Amazon QuickSight, Oracle Data Visualization, and all of these kind of different tools. So they really are, and you could potentially kind of use all of them even, right? And depending on kind of what your kind of skill level is, some of these are going to be easier to use. A lot of people don't realize, people are trying to learn up things like Tableau and Qlikview and different things like that. But to be honest, things like Tableau are self-service data visualization tools. They're actually much, much easier to use than something like Excel even, because you just click a few buttons and you get these amazing data visualizations. Very, very powerful and quick for exploratory data analysis and putting together nice looking visualizations. Now, when it comes to distribution of your reports, though, and in some of these tools, that's where these companies start to make some of their money, right? So Excel has generally always been pretty easy in terms of everybody has a copy, so it's relatively easy to distribute reports, at least if everybody has Excel. The one kind of caveat to that is that, when you make a report in Excel, you kind of have to make sure that other people also have the same version of Excel. Especially if you're using some of the new features, the features between Windows and Mac are sometimes different, and sometimes people actually don't have Excel at all, right? So some of these other tools, when you're like building reports using something like R or say Tableau, a couple of sort of universal formats for producing the reports could be something like PDF files, are pretty kind of stock standard. Of course, you could do that with Excel as well, or web-based formats. And those are probably the most interesting ones because, well, everybody has a web browser, right? So it's the kind of one universal format. It'll automatically scale. You can add interactivity to it and all those kind of things. So, I think those are actually pretty good tools, but you need to be a bit more kind of technical to use them. This is where some of the data visualization tools come along. You can make all these kind of reports very, very easily without any kind of coding ability or even the need to put together like formulas together in Excel or anything like that. But when it comes to distribution and sharing, there's typically a licensing cost involved with these different tools. Now, just to give you a little bit more background on, say, the data visualization tools as well. We used to have, well, a long time ago, and these are still lingering around like quite a bit. Even now, you had tools like Crystal Reports and Business Objects and Cognos and different things like that. Well, Cognos not really reporting, but like different tools for building reports. Then we had Qlikview come along. So you might have heard of Qlikview. At that point in time, they had made this revolutionary product because they had this in-memory data processing. And they had very, very sort of interactive reports. The thing is that those dashboards were still pretty much built by developers. And then non-technical users would only get to use the end products of that as opposed to actually building the dashboards themselves. A few years later, you have Tableau come along, and then Tableau basically comes along and completely revolutionizes the market by creating self-service business intelligence tools. So being able to create all the stuff that that a developer would create in, say, Qlikview, but then having anybody being able to do that themselves. So Tableau was first to market with this kind of self-service business intelligence tool. Now, being first meant that they did actually miss out on a lot of features. For instance, there's no kind of data wrangling or data preparation tools that go into Tableau. Also, Tableau started out as a desktop tool, and I think it's kind of still predominantly kind of in that space. Now, I think it has been probably nearly 10 years or something like that since Tableau came out. And so they've been actually around for a reasonable chunk of time now. And for actually a really long time, they didn't really have a lot of competition, right? And so they built up a massive, massive fan following and user base. Now, in the kind of last few years, we've had a number of other players come into the market as well. So Qlikview, they kind of realized that they needed to update their product. And so they came up with a new product called QlikSense. So QlikSense is basically Qlikview version 2, which is a copy of Tableau, right? Microsoft came out with Power BI. And Amazon came out with Amazon QuickSight. And Oracle came out with Oracle Data Visualization. So kind of all the big players coming in and effectively copying the Tableau product. So this kind of hold on the market that Tableau had has very much been commoditized by all these other players coming in. And when Amazon came along as well, the licensing cost for, say, Tableau was maybe $1,000 to $2,000 per year to get a Tableau license, right? Now, this is not just for the people who build the reports, if you want to share the reports, you need to start you need to start forking out licensing costs as well. Now, there are free viewers that you can get for Tableau, so potentially you don't need to spend money to for people to use it. But the problem with the free viewers is that you need to get your user base to install a desktop piece of software, which is really not that convenient. Generally, you're going to get organizations who will then actually pay the kind of more expensive licensing costs so that they can basically serve these things up to a server or something like that, right? That's kind of the more practical way of actually distributing and sharing these reports. And all the other kind of products actually have a very similar type of licensing model. Now, so anyway, when Amazon came along, they effectively cut that pricing by 90%. All right. So they came out with a product which was 1/10 of the cost, right? So this was an amazing thing for the market. And this only happened like in the last couple of years or so. So it's actually very, very recent. But they really, really brought the prices down. And so a lot of these other players, now you have to realize that ClickSense and Power BI had really only just kind of come out themselves. Develop their own kind of Tableau-ish kind of products. And they were originally priced up at the same kind of price point as Tableau. But when AWS QuickSight came along, they actually dropped their prices to match AWS QuickSight, which is a huge win for the market, really, because now these tools are just so much more accessible. Now, what about Tableau? Well, actually, Tableau, they have dropped their prices, but not by, not to like a tenth. They've dropped it by about half, right? So the Tableau pricing is now cheaper, but it's still a lot more expensive than the competition, right? So in terms of popularity, Tableau is still the most popular product. But generally speaking, I probably wouldn't, I wouldn't recommend it for like a business to go off and build a kind of their strategy around using Tableau, just because the licensing cost is just so much more expensive. And I don't think there's actually any significant benefit of using Tableau over some of its competitive products now, especially since the people who are kind of using Tableau, if you're using a self-service business intelligence tool, usually, there's a few reasons. You've got the crowd of people who are less technical, and it makes those tools more accessible to those kind of people. And then you've got the people who are kind of a lot more technical. And then, it still makes a really nice tool for rapid data exploration. But then you're going to go off and use something like R or Python anyway. Because then that allows you to go into more detail. It allows you to do all the data wrangling, which Tableau doesn't. All the data preparation, all your statistical functions, all your code, all your programming. And then actually, even if you build some fancy visualization in Tableau, like I said, the licensing cost is too much to share your reports. So what you're going to do anyway is basically maybe rebuild it in R or Python so that you can get it out into some standard HTML format. So then you can share it with your users at maybe no license cost. But there's different strategies. So I know certain people are using maybe Power BI for this kind of stuff instead. Maybe they'll use Power BI for their sort of distribution server. And probably of all of the data visualization tools available now. I was thinking for a long time about which one that I would kind of actually pick. And out of all of them, I would probably go for the data visualization tools anyway. I'd probably go for Power BI. And the reason for that is because, well, one, it's you can have it online or offline. you can start for free with a free desktop application. So you can start building reports that you can't share. Once you start sharing, you have to start paying for it effectively. But you can get started for free, which is a really big bonus. The data wrangling function of it effectively uses Power Query, right? Which is the same thing. I teach this for Excel, and this is one of the key reasons I kind of teach it for Excel, because a lot of people don't even know that the Power Query feature in Excel kind of even really exists. But if you kind of follow some of my videos, and you'll probably be familiar with some of that. But basically, Power Query allows you to do all of this data wrangling without code, and it's much more robust than VBA, and it allows you to do a lot of stuff that people would traditionally be doing in like SQL databases, different things like that. And just by basically clicking a few buttons. So, and since everybody has Excel installed, Power Query is automatically, it comes as part of Excel 2016. It's a free add-in for Excel 2013. So, it's very, very easy to get a hold of and start using it for, like if you're using Excel, then, I think you should definitely be using Power Query. And if you get a hold of Power BI as well, then you'll see that, well, it's actually pretty much the same thing that allows you to prepare all of your data for the data visualizations in Power BI as well. So definitely a bonus of Power BI there. Also, basically, Power BI, it's Microsoft, right? Now, depending on your kind of views of this, you might think that's like a good thing or a bad thing, depending if you're a bit of a Microsoft fan or not. But basically, the kind of big players right now, you've got Amazon, you've got Google, and you have Microsoft, right? And these are some of the like biggest companies in the world now. And so AWS, Google Cloud, and Microsoft Azure, they all provide cloud-based services. And so they have very, very, very comprehensive technology stacks. And Power BI just happens to be part of the Microsoft technology stack. But it can also be used on any other platform as well. So, even if you weren't working on a Microsoft stack, you could still use Power BI. And that's actually a real bonus, actually. So say you compare this to something like AWS QuickSight. Now, I was really, really excited when AWS QuickSight came out, because it's like, wow, this thing looks really cool, really fast, really scalable, all this kind of stuff. The only problem with it is that Amazon is almost, and I'm sure it'll get to this point eventually, but Amazon's almost a bit ahead of its time, right? So Amazon QuickSight is basically cloud only. It's web-based only, which means there's no desktop app, right? And it really only works with the AWS ecosystem. So if you're not on AWS, if you're not on the AWS ecosystem, then you're not really able to use it, right? Whereas, Power BI or say ClickSense as well, they both have free desktop applications, which you can basically just download and start using straight away. And then you can set up servers for them as well on any of the cloud platforms. So then you can become cloud vendor independent, and then hook them up to whichever data, right? So, but between ClickSense and Power BI, I think, well, they're both, I'm sure they're like really both great products, but Power BI is got the backing of Microsoft basically. So, a real kind of benefit there. Okay, let's talk about some of the other tools. So one of the things I was kind of surprised about, one of the questions I kind of get quite often actually is, when I talk about getting involved in data analysis, data science, and that sort of thing, a lot of times people are often asking about the use of SQL, right? So, things like, maybe you have an Access database or a SQL database or something like that, right? And SQL is really it's a query language, basically, right? Now, there's a lot of things, there's a lot of people who are already educated and trained in databases. So they're used to things like tables and joins, and relational data structures and all this kind of thing, right? And so, they might kind of wonder sometimes, like, well, why would you do that in some of these other tools, like, well, Power Query or R or Python, instead of doing that in a database? And I think the idea is, if you have a lot of data in a database, then you do want to limit the amount of data that you pull down from the database before it gets into some of these other tools. But really, it's really just kind of shrinking and extracting the data so that you can do analysis on it, right? You typically don't want to be doing analysis in a database, particularly a relational database. And there's several reasons for that. Okay. First of all, right now I'm just talking about relational databases, and there are other types of databases as well. But relational databases were basically originally designed for transactions, right? So transactions, like for instance, you've got some point of sale system or something like that, and you're recording each sale item into the system, right? And so traditional relational databases are record-based, or in other words, they're kind of row-based. And because they're used for storing data, all of the data is written to a disk, like a hard disk or a network, some place on the network or something like that. And that actually makes them really, really slow. Now, a lot of times people actually use Access or like SQL Server or something like that as some hack to join like larger data sets, and they think it's really fast because they've only used Excel. And Excel is, if you've only used VLOOKUPs, then, like VLOOKUPs is just ridiculously slow for doing these kind of things. So if you do a join in a database, like already it's looking like it's 1,000 times faster. But it's actually not that fast in comparison to some of the actual data analysis tools. And the reason is, one of the reasons is because, one, if you're using R or Python, everything, or even like Tableau, Power BI, or any of these kind of tools, everything gets shifted in memory. So your data, once it's extracted, shifts into memory. And then just from that, it's already running like, hundreds, if not thousands of times faster than a SQL query, right? So, so SQL is really just for extracting data, or it's not for doing analysis at all. If you want to do any calculations or anything like that, SQL also doesn't have a very rich library of functions for doing different things. You take a look at, say, Microsoft Access. It doesn't even have a median function, right? So kind of how horrible is that? But so its functions, the number of functions for being able to do calculations is just not there. And to be honest, even if it'd just be really slow because it's all disk based. And the other thing is that it's record based. Now here's the other kind of key thing as well. When you're working with data, the shape and structure of it actually kind of makes a big difference, right? So, if you're working with, like everybody's worked with Excel, right? And you work with tables, right? And so you know that a table has got rows and columns, but rows and columns, well, it's a little bit more than that as well. Like I said, a traditional relational database is based on the record. So you have something called a primary key, like a unique identifier that you use to look up individual records, and a unique key that you'll be able to use to do joins on, right? This is the kind of thing that you would do a VLOOKUP in inside of Excel, right? Now, what happens when you're doing data analysis, data science, that sort of things, a lot of time you're looking at aggregated views, right? So what you really want to do is you want to operate on an entire column, right? So you want to perform a function on an entire column. But traditional databases just aren't optimized for working in columns. They're optimized for working on rows, right? So they're just very, very slow for column-based operations. So this is the other thing. When you start moving across to any of these other data analysis tools, then you're going to move to column. Your data is going to be reorganized into columns instead of rows. And that means that the aggregation of columns ends up, again, being hundreds, if not thousands of times faster than a database. Now, a lot of people don't realize this is that there is actually a column store in like an in-memory column store database inside of Excel as well. Now it's not there by default. This is the problem, right? So to traditional Excel, it's not actually organized by rows or columns. It's just a bunch of cells, right? And that makes it, that makes it really, really slow because when you're working with databases, everything's a lot more structured, right? You have each column only contains like a single type of data. And when you start going into things like computer science and different things like that as well, you realize the reason this is important, because when you can explicitly specify what type of data is going to go into a column, then you can allocate the minimum amount of like a memory to actually store that information, right? So instead of maybe taking up, I don't know, for argument's sake, 256 bits or something like that, you could have a column that maybe only takes up 8 bits or 1 bit or something like that, right? So you're storing much, much less information, and because of that, you can you can again run things hundreds of times faster with like the same amount of resource, and so you can do a lot more. And this is how you start getting into bigger sets of data, right? But anyway, I was kind of saying before that Excel has a built-in column store database as well. It's called Power Pivot, right? Now, a lot of people don't realize this exists. Microsoft acquired a company or a product called Vertipack, and this was back. They introduced this in Excel 2010, actually, but this was actually it wasn't built in as such. It was a free add-in. So it was a free add-in for Excel 2010. It was a free add-in for Excel 2013. In 2016. They took away the add-in, and what they did, I'm a little bit disappointed by this actually, but what they did is for Excel 2016, if you have like some business professional version or like some special version of Excel, which not everybody has, then Power Pivot is actually built in. Now, if you don't have that version, you don't even have the option to install the add-in anymore, which I think is a real shame actually. So I don't even know what's going to happen to Power Pivot really, just because now it isn't as available anymore, and it's not like it massively took off before anyway. So I don't know. I mean, it'd be interesting to see how that goes. I mean, I'm assuming they're going to use it for the back end of like Power BI and different things like that as well. But it uses a proprietary language for that called DAX to be able to express different calculations. Whereas, to be honest, I think you're probably much better off using R or Python for that kind of stuff anyway, just because it's a richer, kind of bigger, more popular language with basically tens of thousands of libraries and functions that you can use for both of them. I mean, Microsoft and their technology stack, they also have tools such as Microsoft ML Server. Microsoft ML Server can work with R or Python. It'll take R or Python code and compile that into REST APIs, and then you can access it through your other tools such as Power BI or build a web application on top or whatever, right? So there's you're much better off kind of using those kind of tools. Now, in terms of databases, I was mentioning that the traditional type of database, such as Access or SQL Server or something like that, these are all relational databases, which are all record-based. And record-based basically means they're terrible for analytics, right? So they're really just for storing data, and you'll use SQL to extract that data to use in another tool. But now there are other types of databases as well. So for instance, you've got graph databases, you have document databases, and you have column store databases. So column store databases, things like Spark is kind of like a big one, are basically databases which are used for analysis, right? So you take all your data, rearrange it in columns, and so that anytime you want to aggregate columns, that is really, really fast, right? So so there's lots of different types of databases, but typically these kind of things, they're not really worth it unless you have like really, really quite big data. I mean, when you're looking at something like Spark, we're getting into the areas of distributed computing, right? So these are column store databases that don't just work on a single computer. They're column store databases that work across many computers to store and do the calculations. So you get massive parallel processing. And so, you can just keep on adding nodes, and there's almost kind of no limit to how much data that you can kind of process with these things. Now, when you're dealing with something like R or Python or something like that, you are limited to the amount of the memory that you have on a single computer. Now, that might be kind of more than you think, though, because, just using R, I've managed to, say, load up like 10 million records onto a laptop with 16 gigs of RAM, right? So, I mean, this is not really a massive spec computer or anything like that. And I can still handle 10 million records of data in R with, say, 100 columns, which is like 1 billion cells for Excel, which is just seems like some ridiculous amount if you've only worked with Excel before, right? Then that seems like a lot of data. Now, obviously, you could just kind of increase the RAM on your computer. Like if you get a higher spec computer server, then you can add more RAM, and you can easily get to hundreds of millions of records of data just on a single computer without actually needing to go to things like Spark and different things like that. But I think technologies such as like Hadoop, data lakes, different things like that, they are becoming like very popular these days. And I don't know, data size is a bit of a funny thing in a way. On the one hand, it's like, is 10 million records a lot of records? Is it not a lot of records? I think what you'll find is that once you start getting into data, once you have the capacity to do certain things, you'll find ways to use it, right? So 10 million records seems like a lot until you start adding kind of time series points, right? And when you say take a data set and then you time series it, and you take monthly snapshots for the last 10 years, or you start getting more and more granular, are you going to do it by week or by day or by minute, by second, or whatever it is, then all of a sudden you can build up a very, very big data set very, very quickly. So, just to kind of keep that in mind as well. Anyway, I'm going to take a little break from talking. If anybody has like any questions, then please do kind of pop them through, because then I can try and make this a little bit more relevant, a little bit more interesting. I'd love to know, like, what are people using now? What would you like to use? What are you interested in learning about? Please let me know, and I can talk about that. It'd be great. And just let me know where you are coming in from as well. So some of the tools that I haven't mentioned here that have also kind of been brought up for things like data science and data analytics are things like MATLAB, SAS, and SPSS. Now, I've had the chance to kind of look at the kind of data tooling strategies of like large organizations, and what I can tell you is that these tools are starting to get phased out, right? So, not that they're not great tools and all that sort of thing. It's just that they're very, very expensive to use, right? And there's nothing these days, there isn't really anything in them that you can't do with our Python. So why would you pay, like tens of thousands, if not sometimes hundreds of thousands of dollars to get some of these kind of proprietary tools when you can effectively use the open source tools for free? Now, for a long time, these tools, like even when R and Python were around, companies weren't ready yet to move to them because they didn't have the commercial support. But now you're starting to get bigger players coming to the market, like Microsoft coming in with Microsoft ML Server, which is based on open source programming languages now. So it's R and Python, right? And now that we're getting the commercial support for some of these tools, it's a great thing, because now we can get access to all of these tools effectively for free, right? And it's just the big corporations which are going to pay for the commercial support and licensing for that, so they can, sue somebody if it breaks or doesn't work or something, right? Now, and the other thing about these other tools is that, they tend to be, besides the initial upfront cost of purchasing them, there is also the licensing cost of any additional add-ons as well, right? So, any add-ons, like I mentioned before, R and Python have tens of thousands of libraries that pretty much do any, anything you can think of almost. Somebody's already kind of built a library for it, which massively shortcuts the amount of work that you need to do some really cool stuff. Now, if you're going into MATLAB, SAS, SPSS, then every one of those libraries is an additional license cost. Now, if you're working in a big organization, which, I don't think you'd be using these tools otherwise, right? But if you're working for some sort of organization which has to fork out, which has to open up its purse to be able to, just buy a library because you found a new library that you want to use, then that's basically just a painful process, which just means, you're stuck with very, very basic baseline functionality, right? And so for a lot of things, it's kind of the reason why these tools are really being phased out, unless there's kind of very specific kind of use cases, or you maybe if you have somebody which has a real expertise in a particular tool, and there's some very, very specific library or whatever that maybe needs some of these other tools, then it just doesn't make sense for companies to use these tools. So if you were looking for stuff to study, I would not study any of these tools now. It's just, it just really doesn't make sense to. Yeah. So, anyways, I think there's potentially a lot more I could talk about as well. But I might save that for like another video sometime. Stuff that I think would be interesting to talk about is going a little bit more into depth about all the different types of databases, right? So how are the different types of databases actually different from each other, and what are they actually good for? A lot of it is basically to do with the types of data structures that they use, and the different types of data structures that they use are good for solving different types of problems. And once you actually know those data structures, it's not just good for like thinking about databases, but it's also good for thinking about data structures in all the other tools as well. So I think that would be probably something interesting to go into at another time if people were actually interested in that. As mentioned, I have a video up already, which is the comparison between R and Python. I think, potentially, I do want to go a bit more into sort of Excel versus some of these other tools and stuff as well at some point, because on the one hand, like Excel has, the thing is this, Excel has got 750 million users, so it's kind of the one tool that is almost kind of guaranteed to be there. And that has its ups and downs, right? The upside is that there's always a tool there to use. And if you know how to use it properly, using things like, Power Query and tables and different things like that, then it can actually work pretty well. But for the most part of it, Excel ends up being a lot of a headache for most people, just because the people who don't know how to use it badly, and they, it's all the it's probably all the 745 million Excel users who end up creating all the bad data. So I think having some education around that will definitely make basically everybody's lives easier. The people who are not necessarily working with data day to day, they could get their jobs done a lot easier. And then the data would be cleaner for all the people who do work with data every day. So, that's why I think it's pretty important to talk about Excel as well. But anyway, I think that is enough for me today. So if you want to find out about any more of my stuff, you can check out my channel. You can check out my website, which is www.datastrategywithjonathan.com. So I got some free training up there, and I'm looking to update some of that soon as well. So, please feel free to check that out. But anyway, thank you very much, and I will see you next time.